ProfessorBlackOps. You see it. Let's get it. This is STIGs. We're going to talk about web server generic security. Then you see the popular NGINX, struggling today, web server in there. So actually, what does that mean? That means this is STIGs doesn't have a specific checklist for that particular technology. So then they usually have a generic technology for that branch or division of technology. Like Nginx is a web server, so we can use the generic web server checks on it to make sure we qualify to run a federal level compliance, get a federal contract, and do federal business. So let's quickly step through some of these. So Nginx is a web server software underlying hardware, usually HTTP requests, network protocol, creating a web page or website. The secure variant of that, of course, is HTTPS. We want everybody to be secure, using the proper ciphers and all that good stuff. Commonly a web browser or web crawler, making a request for a specific resource using HTTP or HTTPS. And the server will respond with the contents or error page. The server can also accept and store resources from the user if configured to do so. So you've seen websites where you can upload PDFs, upload documentation. So myriad of things a web server can do. So that's the standard NIST technology. National Institute of Standards and Technology is NIST, which reports to FISMA, Federal Information Security Management, which serves the Department of Defense, DoD. Federal IT security pros within DoD must comply with technical testing and hardware framework known as the acronym of STIG, or Security Technical Implementation Guidelines. Once again, that's a checklist to harden that particular technology. For the generic web server checks, we would actually put them on Nginx web server. I'm actually going to start doing labs hopefully in July. There were 0 high checks, medium checks 96, and low checks 0. So usually when you're using generic technology, they won't have any high checks. So most of their stuff will be, the majority of their checks will be medium, which is, for me, is kind of disheartening. But it is what it is. We have 96 good checks to put on our web server to make sure we're secure. A couple of checks we're reading, not a crazy amount of them. Web server must limit the number of allowed simultaneous session requests. The web server includes the ability to control the number of users or user session that utilize the web server, limiting the number of allowed users and user sessions, helpful in limiting the risk related to denial of service. Right. So if you can say this web server can only take 5,000 connections, if somebody tried to do a denial of service, right, the web server would just stop at 5,000. It wouldn't go to 1,000,000 and run out of memory and stop working, right? So that's why you want to limit the number of sessions. The web server must perform server-side session management. Session management is a practice of protecting the bulk of the user authentication identification. Storing the data can occur in the client system or on the server. When the session information is stored on the client, the session ID along with the user authorization and identification number is sent along with the client. So that's why you want to actually keep all the session information in the server. Because if you keep it on the client, like I said, the biggest disadvantages, all three of those can be used to hijack your session because the information is actually on the client. Web server must generate information to be used by the external application or entities to monitor and control remote access. Remote access to web servers is any access that communication through an external or non-organization controlled network. Remote access can be used to access hosted application and perform management, providing remote access information to external monitoring. Organization can monitor for cyber attacks and monitor compliance with the remote access policy, right? So you need to be logging that stuff so you can kind of figure out what's going on. Actually, you can figure out what's going on in real time, right? Web server must use encryption strength in accordance with the categorization of the data hosted by the web server when a remote connection is provided. The web server has several remote communication channels. Example, users using requests for HTTP and HTTPS communications to a backend, communications to authentication. So they just send all that stuff should be encrypted so nobody can snoop your technology using the proper keys, HTTPS for a web server. The web server must use cryptographic to protect the integrity of the remote session. Data exchange between the user and web server can range from static to credentials to log on. Even when data appears to be static, non display logic information may expose business logic or trusted systems to the relationship. So, part of the encryption is integrity, making sure nobody's listening to your sessions in the middle or trying to hijack it. So, there's things called nonce where you send a ID along with your encryption to make sure nobody's taking your packets and replaying them out of order. So now we're going to just talk about classic architecture. Right there after the load balancer is where NGINX will go on the classic three-tier web server because NGINX, of course, is a web server. That's the zero trust for AWS. And once again, the NGINX will show right there. We have some slides coming up that's going to actually break that down a little more. There's the NGINX right there and with the big green N. So the internet user would come in, hit the NGINX web server, then the web server would actually pass the data on to the application server of the database. All right, so that's NGINX AWS load balancer. And right here, NGINX shows that it also has a load balancer that will actually go to other web servers, right? So the load balancer of NGINX would actually go to the web server at the bottom of it. So NGINX has a web server with a lot of capability. AWS has actually used that capability. So you'll see in the next slides where they actually combine forces to try to use the best of each other's technology. NGINX and AWS scale your application to the new heights with NGINX and AWS. So actually, NGINX is a partner of AWS. So they're actually, once again, working on the zero trust, trying to lock down the bad guys. That shows you the AWS web page. Click on that button, you can spin up NGINX with AWS. I'm sure we'll be doing this hopefully in July. I'll pick out some technologies and start spinning them up in AWS, hopefully on their free tier. So this is the NGINX Zero Trust. So if you look to you see the VPC, you see the NAT, you see the Linux Bastion host, you see each of the Linux web servers, multi-tier. So I'll read a couple lines to talk about the Zero Trust part of that. They call this the Quick Start. Use the Quick Start to automatically set up a following NGINX Plus environment on AWS. So the cool thing is you can click a button and you actually have that set up in an environment ready for you to go. That's actually at Zero Trust. So we definitely will probably do that. Click the AWS NGINX Quick Start and put a couple applications out there. So part of the Quick Start is you get a virtual private cloud that spans 2 availability zones, 2 subnets, public and private. The Internet Gateway allows access to the Internet to the public subnets. In the public subnet, managing NAT gateways to allow outbound Internet traffic for the resources in the private subnet. In the public subnet, the Linux Bastion host is an auto-scaling group to allow inbound SSH to access the EC2 instances to both public and private. In the private subnet, the NGINX Plus auto-scaling group, so NGINX Plus load balancing instance can maintain application availability and scale up and down. So let's count it at a high level. You see the chart. Once again, hopefully in July, we'll actually get more detail into what those look like. We're actually do an Nmap Plus on a Linux box just to make sure the VPC and the controlling of the network for the CIDR and the subnets are actually working. So we're actually going to hopefully walk through all that in the near future. Once again, NGINX Zero Trust with the partnership AWS. I just kind of want to walk through the generic STIGs. What would that look like if you apply that on NGINX? NGINX, I wouldn't call it generic web server, but the STIGs just didn't have application checklist for NGINX yet. So once again, just talking high level STIGs, Zero Trust, what would that look like in VPC? You can actually see the flow of it in the VPC charts. Once again, Professor Black Ops, please subscribe.